When zinc metal is placed in a solution of copper 2, some copper metal plates out on the zinc. During this process, copper 2 ions in the copper solution are reduced to copper metal. This can be written as the following half reaction that you see below. Electrons are needed to reduce the copper ions, and these electrons come from the zinc metal being oxidized. Below is the half reaction for the oxidation of zinc. You should notice that the sign of the cell potential for this half reaction has been reversed because it's an oxidation. Adding these two half reactions together, we get the net reaction for the reduction of copper 2 by zinc metal. Notice that in this reaction, electrons move from zinc metal to copper ions. The positive cell potential of 1.10 volts allows us to predict that this reaction occurs spontaneously. What if we could separate each half reaction into separate components and connect them with a wire? Could we get the electrons to move across the wire? Let's see if we can do this. This beaker contains a solution of 1 molar zinc ions. I'm going to place a strip of zinc metal into this solution of zinc. Notice that this beaker now contains all the components of our oxidation half reaction. The zinc metal in this compartment will be called the anode. The anode is the electrode at which oxidation occurs. Okay, now this second beaker contains a solution of 1 molar copper ions. I'll place this strip of copper metal into the copper solution. This beaker now contains all the components of our reduction half reaction. The electrode where reduction occurs is called the cathode, so in this case copper metal is the cathode. Let's connect both of these so-called half cells by a wire to see if we can get a flow of electrons across the wire from the zinc to the copper. If this happens, we'll see a readout of voltage on the computer screen. There's no voltage. Here's the problem. Electrons do spontaneously flow at first from the zinc to the copper. But when they do this, the anode becomes positive and the cathode becomes negative. Because of this, it immediately becomes the case that the negative electrons cannot leave the anode and enter the cathode because electrons are repelled by negative and attracted to positive. There's no way we're going to get electrons to leave a positive and flow towards a negative. We can fix this situation by connecting the half cells with a paper towel that's been soaked in some salt water. Hey, look at that! We're getting voltage! And the voltage output is very close to the 1.1 volts we predicted using standard reduction potentials. The salty paper towel is what's called a salt bridge. With the salt bridge in place, every electron that leaves the cathode is balanced by a negative chloride ion that flows into the anode from the paper towel. This keeps the charges balanced. It could also be the case that the charge remains balanced if a positive sodium ion flows into the cathode each time an electron enters the cathode. In essence, the salt bridge allows us to complete the circuit. Human beings contain a lot of ions. I wonder if I could act as a salt bridge, completing the circuit between the two half cells. Looks like we're getting a little bit of voltage here. Maybe my gloves are insulating the flow of ions a bit. Let's take them off and see if it works any better. Would you look at that? It's kind of fun being an active part of a chemistry experiment. Let's use this diagram here to help us recap. What I've constructed here is called a voltaic cell. Sometimes these are called galvanic cells. To make a voltaic cell, the components of each half cell are physically separated and connected with a wire. The metal surface where oxidation takes place is called the anode, while the metal where reduction takes place is called the cathode. A salt bridge is used to connect the two half cells. Electrons flow from the anode to the cathode, while negative ions flow through the salt bridge from the cathode to the anode. Positive ions flow in the other direction from anode to cathode. Let's do a little experiment here to finish up. What do you think will happen if I reverse the wires so that the copper half cell is connected to the black wire and the zinc half cell is connected to the red wire? It looks like everything's the same except the sign is reversed. Did you guess that would happen? Let me know in the comments if you got it right. Thanks for watching.